Hello, Algebra 1 students. Mr. Fort here with another homework tutorial. This is 512, problems 22 to 27. Let's solve a couple of systems of equations. This first one is a definite substitution system because y is equal to 3x plus 1. So x plus 2 times 3x plus 1 must equal negative 5. That's the exact same equation as the top equation. The only difference is that we replace the y with 3x plus 1. From here, it's all mechanics. You got to distribute that 2 and get 6x plus 2. You get 6x plus, 7x, 7x plus 2 now equals negative 5. Subtract the 2 over, and you get 7x equals negative 7, which is good news for you because that means that x is going to be negative 1. We need to divide that 7 over. And then if x is negative 1, you take that all the way back to the top of the problem. Y is equal to 3 times that negative 1 plus 1, which gives us negative 3 plus 1, which gives us y equals negative 2. And that is your answer, negative 1, negative 2. Let's look at B for a moment here. Again, we have an elimination system, but not an easy elimination system. Here we have the numbers don't quite match up. 2 never matches onto x, and 3 doesn't match onto 2. The best way to handle this would be to multiply the bottom equation by 2. And what that's going to do, it's going to leave the top equation exactly the same. But the bottom equation becomes 2x minus 4y equals 2. And that is nice because what we can do now is we can actually subtract the 2 x's that we have there. And we can cancel that out. We can eliminate it. Let's subtract it. Keep in mind, though, we are subtracting. This is kind of tricky. 3 minus negative 4 is going to give you 7y. And 9 minus 2 is 7, which means that y is equal to 1. We still got to solve for x also, so let's take this up and plug it in right there. We'll get x minus 2 times 1 equals 1, which is x minus 2 equals 1. And if you add the 2 over to both sides, x is equal to 3. So 3, 1 is the best answer that we have for that problem. Okay, let's move on to the next question. We're going to solve for indicated variables, a skill we shouldn't lose. We're not solving these for numbers. We're going to get equations for answers. So first thing, solving for b, we basically want to get rid of everything that's not b. So that's the entire an term, which you actually can just subtract in one piece. Subtract the an from both sides. It cancels out over here, and you get t minus an equals b, and that is solved for b. There you go. Question B is very similar. We need to solve this for y, so we need to get the y by itself. Let's start by getting rid of the a chunk. In general, if you've got a plus or minus thing attached to it, you want to get rid of that first. This is y over 3 equals a plus b. We don't know what a or b is, so we cannot combine them in any meaningful way. Next, we're going to multiply by 3 in order to cancel out that dividing by 3 happening on the left. These cancel out, and you get y equals 3 times the quantity a plus b. It must be in parentheses like that also. If you want to distribute the 3, it would be 3a plus 3b, which is also correct, but I like the first answer better. Let's look at question C, which is incredibly easy. All we got to do is solve for y. Y is currently being divided by x, so let's multiply it by x on both sides, and that will cancel out on the right side, leaving xm equals y. And honestly, that's all there is to it. Or y equals xm if you wanted to. Over here on question D, this is going to be a little trickier to solve for x. Currently x is in the bottom of the fraction, so we want to get it out of there actually. Let's subtract it or multiply x on both sides. What that does is it cancels out the x over here, but now it moves it so that x is now kind of on the top level. X times m equals y over there. And now we want to divide by m on both sides, and that will allow us to solve for x and only x. It'll equal y divided by m. That is the best way to answer that question, I think, that I know of. Okay, let's move on to the next thing. Here we got some more exponent rules. Those certainly are not going anywhere. Actually really important as we move into chapter 5, which is all about exponents. In this first question, you got kind of 3 categories. You got 6 divided by 3. You've got x squared divided by x. And you've got y to the third divided by y. 6 divided by 3 is 2. X squared divided by x is just x. and y to the third divided by y is y squared. Technically, you're doing 2 minus 1 for the x's and 3 minus 1 for the y's, if you want to think about it that way. Over here on question B, you've got negative mn to the third power. This is simply negative m to the third times n to the third. There's really not much more to say about it other than you actually can kind of distribute this 3, and it's because the main operation right here is multiplication. Next question, in question C, this is very similar, except now it's a negative 3. Now, I think the best thing to do with a negative exponent is to move it to the bottom of a fraction, 1 over mn to the third, like that. Now, you are allowed to do what you did in the previous problem. Just distribute that 3, m to the third, n to the third. Either one of these answers is technically correct. I think the one on the right is probably more correct, but we'll move on. Question D. Here you have your scientific notation problem du jour. We're probably going to need the calculator for this one, but let's handle the 10 to the x power first. For this one, you're just going to subtract the exponents like you would normally. So we're going to have some number times 10, but it'll be to the negative 5th power, like that. Negative 2 minus 3 for negative 5. The other number is just going to be whatever 3.2 divided by 8 is, and I'm going to ask a calculator what that is because I have no idea. It's 0.4. Well, that's nice. How about 0.4 times 10 to the negative 5th power? I like that answer. So again, to be brief, all you do is divide these two numbers to get that number and subtract negative 2 minus 3 to get negative 5. On the next page, we've got a bunch of problems here. All we got to do is determine the domain and the range of each of the following graphs. So let's put a D and an R down for every one of them. Let's do domain all at once, and then we'll come back and do range all at once because it'll give us a chance to remember how that works. Domain is simply all of the numbers touched by a vertical line, all of the x values in this problem. Now, because of the arrows that are on the endpoints of the parabola shapes, here, and also here, the domain of every single one of these graphs is all real numbers. Or this fun symbol, all real numbers. There is no point on any of these graphs where an x value does not exist. The vertical line will always touch all of the graphs. The range, however, if you turn this whole agreement to the other side, is not to all real numbers. The range of this first graph goes from negative infinity all the way up to positive 1. And so the range here would be from negative infinity, comma, 1. And 1 is included in a square bracket because it is part of the range right there. The next question is kind of the same thing but flipped upside down. This one starts at negative 1 and goes up to infinity. So the range goes from negative 1, comma, positive infinity, and close right there. Question C starts at negative infinity and comes up and hits 0 and then stops. So negative infinity to 0. The infinity always gets a round parentheses, 0 gets a square bracket technically. And question D starts at negative 1 on y and then goes up forever. So it is a square bracket, negative 1, comma, infinity, parentheses, like that. Great. Question 526, the graph at right compares the age and the number of pets for a certain population. Describe the association of this population, which means we're going to select basically one from every list of numbers. Strong or weak, linear or nonlinear, positive or negative. Man, it does not appear to be any relationship whatsoever. I mean, yeah, you can make a line of best fit through this. It looks kind of like that. But I would say this is a weak, linear, positive relationship. Whatever is, it's weak, and that doesn't really, and then nothing else really matters after that. 527 says, at an aunt's wedding, Nicholas collected the data about an ice sculpture that was about to completely melt. The graph of his data is shown at right. Calculate the equation of the line of best fit. Well, the line of best fit in this case, unlike the previous problem, is very strong. In fact, it's a pretty obvious straight line right there. Now, you could really easily calculate the change in y to be negative 10 and the change in x to be 4. And the reason why it's negative is because it's going down. It's losing height. This is an ice sculpture that's melting, so its slope should be negative. So as far as the line of best fit goes, it looks like the y-intercept is 10. Usually we start there. And the slope in this problem is going to be negative 10 over 4, or negative 5 over 2. So I think the equation of the best line of best fit would be negative 5 over 2 times x plus 10. Kind of like that. Based on your equation, how tall was the ice sculpture 1 hour before it started melting? That's interesting. 1 hour before would mean that we're going to plug in x equals -1 into this thing. So let's figure out why when x is -1. -5 times -1 plus 10. What this is going to do mathematically is actually make 5/2 into a positive number. 5/2, by the way, is 2.5 plus 10. And so the answer here, I think, is 12.5. Is it feet or inches? Inches. Like that. There you go. Hope you had a good one. See you in a quick little 10-minute video. I will see you in the next one. You guys are amazing. I'll see you next time.